Hey, pre-calc students, this is Mr. Beck. Today we're going to be talking about our last section in Chapter 7, which we're going to call the double and the half-angle formulas. Now, the reason why we call them the double and the half-angle formulas is because what happens if we want to know double of a certain angle? So when it comes to double of a certain angle, what we're going to do is we're going to use this idea that 2 theta is equivalent to theta plus theta. So we're going to start from our sum formulas for sine. So if I want to know the sine of theta plus theta, which eventually is what I'm going to call the sine of 2 theta, then this is the sine of theta cosine theta plus cosine theta sine theta. Now, those are the exact same terms, and because those are the exact same terms, we can combine them together into one term, 2 sine of theta cosine theta. So this is going to be our first equivalence, or our first formula for the double angles. If I want to know double of an angle, then I can figure it out by 2 sine theta cosine theta. Let's do the same thing for cosine. We have the sum angle formula for cosine here. We're going to say this is the cosine of theta plus theta. So that would be cosine of the first, cosine of the second, minus sine of the first, sine of the second. Now, hopefully you recognize that those are the exact same angle. So this is really cosine squared of theta minus sine squared of theta. Don't be confused that this is cosine squared minus sine squared, not plus sine squared. Because if it were plus sine squared, but remember if this is cosine squared plus sine squared, that's equivalent to 1. But cosine squared minus sine squared is equivalent to cosine of 2 theta. Then tangent, we have tangent of alpha plus tangent of beta over 1 minus tangent alpha tangent beta. So the tangent of theta plus theta is tangent theta plus tangent theta over 1 minus tangent theta, also known as 2 tangent of theta over 1 minus tangent squared theta. So our double angle formula for tangent is 2 tangent theta over 1 minus tangent squared theta. I forgot to highlight this one. Cosine of theta is cosine squared minus sine squared. Now, with cosine squared minus sine squared, cosine has multiple ways that we could write it really. And it stems from the fact that we know that cosine squared is 1 minus sine squared, and sine squared is 1 minus cosine squared. So if we do a substitution, and we replace the cosine squared with a 1 minus sine squared, and we simplify, we get our next of the cosine double angle formulas. But it's really the exact same formula, just written only in terms of sine, not cosine. And then we could do the same thing. We could replace the sine squared with the 1 minus cosine squared, which is what I do here. And then simplify into the last of the double angle formulas for cosine. So everything highlighted here would be our double angle formulas for all the different, for the sine, cosine, and tangent. If we wanted to know the secant, cosecant, and cotangent, all we have to do is reciprocate each one of these. So for instance, if I wanted to know the cosecant of 2 theta, that would be 2 theta, then that would be 1 over 2 sine theta cosine theta, or also known as 1/2 cosecant theta, secant theta, sorry, cosecant theta, secant theta. Then we could do the same for the other ones if we wanted to. But, let's go ahead and apply it. So if you notice, I have all the double angle formulas here. Now let me erase this triangle because that shows the connection that I want to show later. So my goal is I want to find the sine of 2 theta. If I want to find the sine of 2 theta, but I'm given cosecant of theta. So this is going to be very reminiscent of what we've done all chapter, where I'm given a ratio. Really, I had 2 chapters now. I'm given a ratio, and then I need to find another ratio. So the ratio I'm given is the cosecant ratio, which would be r over y. How did I know I'm in quadrant 4? I'm really told that in the directions. Please make sure you read the directions. We could use Pythagorean theorem to figure out what our x value is. Please keep in mind we want the positive square root, not the negative square root, because we are working in quadrant 4. So let's apply the formula. Sine of 2 theta is 2 sine theta cosine theta. And we know that the sine of theta is going to be y over r, which is how I get the negative 3/7. Cosine of theta is x over r, which is how I get the 2 square root of 10 over 7. Therefore, I multiply it through. Sine of theta is negative 12 square root of 10 over 49. Now, what does this mean? And that's what I had in pink that I'm going to go ahead and re-highlight in pink. What happens if I want to know double the angle? So suppose I extend this side such that I have this angle. Ooh, very badly drawn, so let's try that one more time. So what happens if I extend this side out so that this angle is equivalent to the other angle? Well, what I just found was the sine ratio of this new big angle. Sine ratio is going to be the y value. So this is negative 12 square root of 10. And then this is 49. So what happens if I want to extend that angle? There are a lot of engineering applications to this kind of problem. That if I extend the angle or double the angle, how does that affect all the other ratios we see? So there you go. Cosine of 2 theta. Cosine of 2 theta, we can apply the formulas. If you notice, I've applied 2 different formulas. The first one was 2 cosine squared minus 1. The second one was 1 minus 2 sine squared. Remember, I knew my cosine ratio was 2 squared root of 10 over 7. My sine ratio was 3/7. Worked through the math, and I get the same answer either way we do it. So it doesn't really matter which approach we use. We just have to use one of the formulas and go with it. Tangent 2 theta. Tangent 2 theta, so first we have to know the tangent of theta, which I'm telling you is negative 3 over 2 square root of 10. Going back to the triangle that we drew here, hopefully that makes sense. That's negative 3 over 2 square root of 10. So when we do that, 2 times that over 1 minus that squared. So 2 times the tangent over 1 minus the tangent squared. Then do some math. Do some more math. Remember, when you square the radical, you're squaring both the 2 and the square root of 10. And then I like to multiply by the LCD of numerator and denominator to get that expression, which points out a perfect opportunity that, well, isn't tangent of 2 theta equivalent to sine of 2 theta over cosine of 2 theta? So if I take the sine of 2 theta, which I have here, it's not showing up on the screen just yet. There we go. And I take my cosine of 2 theta and I divide those, you'll see that I will get, indeed, that tangent of 2 theta. So great opportunity. We could really use some trig identities if we were doing this, and hopefully you're getting a little bit better with those trig identities. But if you notice, I'm proving all of these, and I'm showing you these relationships because that's the identity. Next problem, I have a point centered on a circle. I have a point on a circle centered at the origin. Radius is 6. If you notice, I drew out that situation. I did not say in the problem whether this is in quadrant 1 or quadrant 2, and I know it's one of those 2 quadrants because the y value is positive. So in part A, I'm telling you quadrant 2, so I drew out the triangle in the quadrant 2. Cosine ratio, I had to find the x value. So to find the x value, we are going to do the x squared plus y squared equals r squared again. So x squared plus 9 equals 36. X squared is 27. So x would be the positive or negative square root of 27, which is plus or minus 3 square root of 3. If we are working in quadrant 2, which is what I have here, it's the negative. And then the other problem, I'm going to have the positive because I'm working in quadrant 1. But anyway, cosine ratio is negative 3 square root of 3 over 6, which we could reduce to negative square root of 3 over 2. Then if I apply the cosine double angle formula, that's cosine squared minus sine squared. I just found my cosine. My sine is opposite of hypotenuse, which is 1/2. So 3/4 minus 1/4 does give me 1/2. If I were working for part B, I found the tangent ratio because, oops, not that one. I found the tangent ratio because I was trying to find the tangent of 2 theta. So I'm using my formula. So plug in my tangent of theta, simplify, and then I multiply by 3 over 3 again, which gives me just the square root of 3 when I do the arithmetic. Now, perfect opportunity to go back and say, this ratio of negative 3 square root of 3 over 2, I do know, since this is in quadrant 2, this really should be, and I'm going to change colors so we can see a little bit better. This angle right here should be 5 pi over 6. Now, if I double that, I double 5 pi over 6, I get 5 pi over 3. So what is the cosine of 2 times 5 pi over 6? Cosine of 5 pi over 3, which is indeed 1/2. So I didn't go there. That's what we got right there. So even though I didn't really officially know the angle to begin with, I was still able to establish the relationship. Where here, if I look at this, this should be pi over 6. So if I double pi over 6, I say, what is the tangent of 2 times pi over 6? That would be the tangent of pi over 3. And the tangent of pi over 3 is the square root of 3, which confirms what I found using the double angle formula for tangent. So obviously, if I'm given a situation like this, I want to take the easier approach to this. However, it's nice to really show both sides. We don't always want to take the easy approach. Next set of directions, solve. Please make sure you're reading the directions because these directions say solve. Next set of directions say establish the identities. So these problems will look kind of the same, but two different things are going to be applied. So make sure you read the directions. I'm solving from 0 to 2 pi. Now, to get an idea of what's going to happen here, I'm going to go to Desmos. And I have sine of 2x and cosine of x graphed here. Sine of 2x is the red, cosine of x is the green. So if I look for the intersection points of these two graphs from 0 to 2 pi, those are going to give me the solutions that I should find. So pi over 6, pi over 2, 5 pi over 6, 3 pi over 2 solutions. Now, if I go back here and I solve, a common mistake people make is they divide by cosine. Now, if you divide by cosine of theta, you're going to get a situation that looks like this, which only gives you two solutions. So by dividing by cosine, you just lost two of the solutions. So please don't do this. And I'm going to shout no many times. Don't ever divide by the function. Instead, subtract it over so we can factor out that cosine. By factoring out the cosine, now we could set that cosine equal to 0, and we get the sine equals 1/2, which, yes, that's what we did over here, but that's what allows us to find our two additional solutions. So please, please, please don't ever just get rid of a solution. And getting rid of the solution would be dividing by the cosine. So continuing on, next problem, cosine of 2 theta plus cosine of 4 theta equals 0. So in a situation like this, the 2 theta and the 4 theta tend to mess with people's heads a little bit. So let's simplify, and we're going to do a substitution. I'm going to say x equals 2 theta. So that's how I got cosine of x. With that substitution, if x is 2 theta, this is cosine of 2x. And now I could use the double angle formula, taking the cosine of 2x into 2 cosine squared x minus 1. Now, why did I choose that one? And this is where the problem solving is going to come from. Why choose this one? Because my resulting equation has only cosines in it, which then I could rearrange because this is a quadratic cosine. That quadratic cosine, then I can solve that the first one equals 0. So the first one equals 0, and then the second one equals 0. And my pen just stopped working suddenly, so bear with me on this one. Hopefully. And there we go. Okay. So then the first one equals 0, and then I can solve. Now, remember, we get to a point that x represented cosine of 2 theta. So if you remember, we set 2 theta equal to 2 full rotations. So the first rotation, where cosine equals 1/2, is pi over 3 and 5 pi over 3. The second rotation is 7 pi over 3 and 11 pi over 3, and that's because we add 2 pi to each one of these. And once again, my pen just kind of cut out on me. So you add 2 pi to each one of those. All right, then don't forget, we still have the cosine of x plus 1 equals 0, which is what we have down here. So the cosine of x plus 1 equals 0. And then I solve to get theta, again, x represents 2 theta. So I have the cosine of 2 theta equals -1. So theta ends up being pi over 2 and 3 pi over 2. Now what we could do is we can go back to Desmos, and that's really what I have here. I have this other equation that says where does cosine of 2x plus cosine of 4x. I want to know where does that equal 0. And the 5 solutions that I just solved algebraically, sorry, 6 solutions that I solved algebraically, we see right here. I do like to go back because this is just kind of a refresher of working with 7.3. How did I know how many solutions that I was going to be working with? to find the number of solutions I'm going to be working with. I'm waiting for my screen to catch up with me. Let's try this one more time. It's stuck on Desmos. I can close out Desmos. There we go. There we go. All right. How many solutions am I going to be looking for? What I could do is I could focus on this 4 theta right here. This tells me there should be a total of 8 solutions. Now those 8 solutions will come from, 4 of them come from like the first one factored. The other 4 should come from the other one factored, but it's not 4 that we're going to have. It's only going to be 2 because this is a coterminal, or this is a cosine equals 1 or cosine equals -1, which only yields a solution. Anyway, next set of directions. With the next set of directions, establish the identities. Typically, we tell you guys work from the more complicated side to the easier side. Now, the more complicated side does really resemble the right side. However, I would say that 3 theta is the more complicated version of what we need to do. That 3 theta is bad. We're not used to it. What we have to do is we have to do what we did at the beginning of this lesson and break it up into the sum of difference, or sorry, the sum of theta and theta, which then the sum formula, sine of the first, cosine of the second, cosine of the first, sine of the second. And then I'm going to use the double angle formula for cosine. So cosine of 2 theta, I am choosing to use the sine version of it because I'm looking at my overall answer, and that's kind of leading me towards I want to get everything in terms of sines, which then I'll distribute. Now, the sine of 2 theta, I write as 2 sine theta cosine theta. So that gives me, when I distribute, not distribute, just multiply, I get that expression. Now, I do have a cosine squared here, which I can replace with 1 minus sine squared. So I have that expression, and then distribute that second set of terms. I guess it's the third term. And then combine together into one expression, which is what I'm trying to find. So if you ever see a 3 theta, your thought is let's break it up in 2 theta plus 2 theta. If you ever see a 4 theta, you could do 2 times 2 theta, you could do 2 theta plus 2 theta, but really you want to break it up into the sum of a bunch of these. For the tangent of 2 theta equals this, what I chose to do was I chose to turn into sine of 2 theta over cosine of 2 theta. And what prompted me was, hey, that kind of looks like the sine of 2 theta right there. This is a really direct approach. Now, if you would have applied the double angle formula for tangent and worked through it, you would get the same answer, just with a couple more steps. All right, that's what we call the double angles. So let's go back to what we call the half angles. Now, the half angles are really going to be just based off of the double angle formula. So if you remember, in one of the last problems, I did a substitution where I said, let's let x equal 2 theta. If I let x equal 2 theta, then I'm going to say this is the cosine of x equals that, but I'm going to replace the theta with x over 2. And that's just solving the first one for theta. Now, if I rearrange and then I divide both sides by 2, then I take the square root of both sides, I will get this expression. Now, what I have in green says plus or minus. Usually when we write these together, we write plus or minus like that. Now, I'm stressing this is going to be the positive or the negative. And where this is important, that positive or negative, and let me write this out, this plus or minus is based on the quadrant the x over 2 is in. So for instance, I have this situation down here that I said, okay, what if the angle I'm trying to find is 150? Now, first of all, we wouldn't do this with 150 because, yes, we know the sine of 150, the sine of 150 is 1/2. Now, if I were going to say we're using 150, 150 is in quadrant 2. I'm going to have to double that. I'm going to have to double that to say the sine of 150 is equivalent to the sine of 300 over 2. Because we're in quadrant 2, the sign is positive. Therefore, we would take the positive of 1 minus cosine of 300 over 2. Now we could do the same thing with the second double angle formula that we derived over here. If we put this as x and x over 2, solve this for cosine of x over 2, which is what I ended up getting here, I now have the positive or the negative 1 plus cosine of x over 2. So going back to my relationship, that if I said that the angle that I'm looking for is 150, cosine is negative in quadrant 2, so we would take the negative square root of that expression. Notice that these expressions look very, very similar to each other, and that's because really a lot of the trigonometry, it's all loosely based off of each other. So I mean, everything, we could put everything in terms of sine, and I know that most people would not want to do that, but we could put everything in terms of sine to make it easier, or to make it just one expression. Now the tangent, half angle formula, is the sine of x over 2 over the cosine of x over 2, which if we multiply by 2 over 2, yields us this expression. Now, perfectly valid expression, it's not the one that I would recommend most people use. Sometimes it's beneficial, like if cosine is 1/2, sure, let's use it, because then we could just do some quick arithmetic in there. Usually though, cosine is like the square root of 2 over 2, square root of 3 over 2, or something a little bit nastier. So if I multiply that expression by, let's zoom in, if I multiply that expression by the square root of 1 minus cosine of x, or the square root of 1 minus cosine of x, we get the one that I most highly recommend. The reason why I highly recommend this is, number one, if you notice, we don't have to determine whether it's positive or negative to determine the quadrant. And the reason for that is because this mixture of sine and cosine really will get the positive or the negative relationship there. Now the second thing is my denominator only has one factor, or only one term. Since my denominator only has one term, then it's going to make working with this a little bit easier at the end. Versus if we do the other one, multiply by the other conjugate, we will get this expression, totally valid, but now suppose I have the cosine of x is the square root of 3 over 2. I now have that expression in my denominator that I'm going to have to simplify, which is not going to be the easiest thing. So we tend to use that second one up there. So let's actually apply the half angle formulas. Now with this problem, 5a and 5b, I actually rewrote 5a so that it's more of a double angle formula, just to kind of reintroduce this idea of the inverse tangent of -2. Because it's the inverse tangent of negative, we draw our triangle in quadrant 4. Basically, the skills that we learned in 7.1, 7.2, and then reused in 7.5 and 7.6, they're all coming back. So I did this as a double angle, and I chose to do the cosine squared minus sine squared, get this as 3/5. For the half angle, I chose to do, this one's also a double angle. Sorry about that. This one's a double angle that I did this as 1 over sine, and then inverse sine of -3/5 ends up giving us a quadrant 4 triangle that we built, a 3, 4, 5 triangle, something that you should be very, very familiar with by now. And so 1 over 2 times the sine, which is -3/5, because 4/5, we multiply it out and reciprocate as -5/24. Now let's get into the half angle formulas. Half angle formulas, I want to find the cosine of 195 degrees. So 195 degrees is in quadrant 3. Cosine is negative in quadrant 3, which is why we're going to be taking the negative square root. Now with that said, I wrote out the formula using the negative square root. Now 195 degrees is half of 390 degrees. So that 390 is what I'm going to be plugging in here to my formula. Cosine of 390, 390 is coterminal with the cosine of 300, or just 30. Cosine of 30 is the square root of 3 over 2. So then if I multiply by 2 over 2 inside there, I will get this expression. Then I know the square root of 4 is 2, so I get this overall expression. Feel free to leave your answer this way. We have a square root within a square root, and there are ways that we can get rid of that. At this point, I feel like we've done enough of the different types of radicals and work with radicals. And honestly, there's so many places to make mistakes, so let's just stop right there. For part B, tangent of 9 pi over 8, we could treat this as half of 9 pi over 4 to use the half angle formula. So I told you I like to use that 1 minus cosine over the sine. And so 1 minus cosine over the sine, cosine of 9 pi over 4. That's coterminal with pi over 4. So that's coterminal with pi over 4. Therefore, square root of 2 over 2. And then when I multiply by 2, I will get this expression. So then I rationalize to get this expression, which if I factor out the 2 from the numerator, I get square root of 2 minus 1, which is how I get my overall. Finally, at the very end, I'm giving you secant of theta is 4, and I'm telling you we're in quadrant 3, so this could have been in quadrant 1 or quadrant 3. Now, one of the things that we do need to know is if this is where theta is at, where is theta over 2 at? So we divide that whole expression by 2 to say that theta over 2 is in quadrant, well, it's between 3 pi over 4 and pi, which is quadrant 2. So theta is in quadrant 4, but theta over 2 is in quadrant 2. Quadrant 2, sine is positive, so we're going to be using the positive square root. So 1 minus 1/4 over 2 gives me this expression. You can hopefully do the math, simplify, rationalize to get my final answer of the square root of 6 all over 4. For part B, I want the cosine of theta over 2. And once again, theta over 2 is in quadrant 2. Cosine is negative, so I want the negative square root. 1 plus cosine over 2. Fill in, let's go ahead and fill in that cosine of theta is 1/4. Now, how do we know cosine of theta is 1/4? I kind of talked over drawing the triangle. Now, we could also say if the secant of theta is 4, the cosine of theta is 1/4 because it's reciprocal. So with that said, do the arithmetic to get to our final answer. And the tangent of 2 theta, if I do this as 1 minus cosine over sine, I get this overall expression. So the tangent of theta over 2 should end up being the sine of theta over 2 over the cosine of theta over 2, which it is when we reduce that. I'm not going to go through the whole reduction of that, but it will end up being that. So 1 minus 1/4 is 3/4. I multiply by the reciprocal here. So I get -3 over the square root of 15, which I reduce like so. There is a lot of arithmetic, a lot of places where students can make little mistakes. Honestly, where adults can make little mistakes as well. So please, please, please just be very cautious and careful as you're going through all of the problems. So signing off, and that's the end of our chapter 7. Have an amazing day, guys.